Hello everyone! In this video, we will explain two methods to determine if your fertilizer injectors are working properly. It's important to determine if your injectors are functioning properly at least once before the growing season begins. Having a fertilizer injector working properly helps you prevent nutrient disorders caused by applying excessive or insufficient fertilizer. For both calibrations, we will prepare by gathering the following materials: pencil and notebook to record values, 1 5-gallon bucket. The larger the volume of water, the more accurate the results, but in most cases, a 5-gallon bucket works well. A graduated cylinder with a minimum of 20 ounces. Calculator, a reliable and properly calibrated electrical conductivity meter, 2 small containers with a minimum capacity of 6.7 ounces, 2 ounces of distilled water. Now that we have all the materials, we can start. The purpose of this method is to check if the injector delivers the correct injection ratio. First, prepare a fresh fertilizer stock solution. Follow the fertilizer manufacturer's instruction for mixing stock solutions that can be found on the label. Turn the water on and charge the system with the concentrated solution. Allow the solution to pass through the injector and garden hose until all the bubbles are eliminated from the system. The time it takes for the fertilizer solution to travel from the stock tank to the end of the attached garden hose will be determined by the length of the suction and garden hoses. When dealing with a small stock solution tank, an effective method to verify the system has been charged is to incorporate blue dye into the stock solution. This enables visual confirmation of when the solution has fully charged the system and is being discharged through the hose. For this demonstration, we will set the injector at 1:100 dilution ratio. First, fill the graduated cylinder with a known amount of concentrated stock solution. We will fill the cylinder with 20 ounces of stock solution. We will call this volume our initial volume. Move the injector siphon or suction hose into the graduated cylinder. At the end of the hose, fill the 5-gallon bucket with the diluted solution up to the top of the bucket. Once the bucket is filled, turn off the hose. Remove the siphon from the graduated cylinder and put it back into the stock solution tank. Record how much concentrated solution is left in the graduated cylinder. We will call this the final volume. In this example, there are 13.6 ounces left. Now we do our calculations. Let's review our units. 5-gallon equals 640 ounces. Therefore, 100th of a gallon, or 1 in 100, would be 6.4 ounces. If the injector is working properly, for this example, there should only be 13.6 ounces left from the initial 20 ounces in the cylinder. To check our numbers, we will use the following equation to calculate our injection ratio. First, do the following subtraction. Initial volume minus final volume. The difference is the injected stock solution used by the injector applied to the 5-gallon bucket. For this example, we subtract 20 ounces minus 13.6 ounces equals 6.4 ounces, which means that to fill out our 5-gallon bucket, we use 6.4 ounces of concentrated stock solution. Then divide the diluted volume by the injected stock solution volume. If the injector is working properly, it should equal the injector ratio of 1:100. In most cases, being within 2 to 3% of this value is sufficient. If your injector is off by too much, you will need to adjust the ratio. Because there are many different commercial available injectors, consult with the manufacturer of your injector for directions on how to adjust the ratio. This method's purpose is to determine if the final fertilizer concentration is correct. In preparation, you will need to know the electrical conductivity of the water source. Use a clean container and collect a sample of clear irrigation water at the nearest point to the water source. Let the water run for a few minutes to clear the pipes and then collect the sample. Avoid any outlets that may have had nutrient solution pass through them. Measure the electrical conductivity. For this example, our electrical conductivity for the irrigation water is 0.2 millisiemens per centimeter. We will now prepare the stock fertilizer solution and adjust the injector to give 200 parts per million nitrogen. In this example, we used 13:13 fertilizer. When setting the injector at 1:100 ratio to reach 200 parts per million nitrogen, we need to apply 20.5 ounces per gallon to prepare our stock solution. Let the solution run through the hose for at least 30 seconds before collecting the sample. Fill the bucket with about 2 gallons of diluted fertilizer solution. For this method, you don't need to track the exact volume of the solution. Collect the sample from a diluted solution using a clean container. Calibrate the EC meter. Rinse the probe with abundant distilled water and then measure the EC concentration of the fertilizer solution and record it. In this example, we got a value of 1.7 millisiemens per centimeter. Now let's make some calculations. Subtract EC value of the fertilizer solution minus the EC value of the irrigation water sample. Therefore, we subtract 1.76 minus 0.21 to give us 1.5 millisiemens per centimeter. Now you will need the label of the fertilizer you're using. For this video, we're using 13:13 fertilizer. Match the target rate to the column with the injection setting. For example, 200 parts per million nitrogen should give an EC of 1.5 millisiemens per centimeter. Similar to the flow method, a 2 to 3% variation is acceptable. If the values are inaccurate, consider that other factors may have played a role. For example, if the scale used to weigh the fertilizer is not calibrated correctly or the water volume of the stock solution is not accurate, your EC would not match the target levels. To ensure the proper operation of an injector, it is advisable to perform both methods. The flow method solely assesses the injector's functionality. If the injector is not functioning properly, it is recommended to contact the manufacturer for needed maintenance, repair, or replacement options. The EC method checks the accuracy of the final fertilizer concentration, which considers factors related to preparing the stock solution, such as weighing the fertilizer accurately, adding the correct volume of water, and applying the proper fertilizer, in addition to injector functionality. Once you have completed both methods, you can then determine the cause of the issue through a process of elimination.